Hi students, welcome back. Today we're going to talk about chapter 14.1c, energy requirement for the changes of state. Yesterday I showed you this heating curve. When I have a solid, I can increase my temperature of my solid. Everything will melt here. When everything is melted, I can increase my temperature of my liquid until my boiling point. I can convert my liquid to a gas at boiling point, and then I can increase temperature again, and I reach higher temperatures of my gas. So let's look at H2O and phase change. Let's assume we have ice and want to convert it to steam. So first what we need to do is we have to increase the temperature of my ice to 0 Celsius. That's the melting point. We can apply the formula Q is mc delta T here. When I'm at melting point, I melt all my ice to water. The temperature is constant at my melting point. The energy to do that, we call it heat of diffusion. When all my ice is melted to water, I'm going to increase the temperature of my water to 100 Celsius. That's the boiling point of water. When I am at 100 Celsius, I can evaporate all my water to steam. The energy to do that, we call it heat of vaporization. And when my water evaporates at 100 Celsius, temperature remains constant at 100 Celsius. Later on, all my water is evaporated, and if I want, I can increase my temperature again to reach higher temperatures of my steam. Well, let's put that in the heating curve. So let's see from A to B, I have to increase my temperature of my ice to 0 Celsius. The heat use, the energy use, is mc delta T with the C value for ice. From B to C, I'm going to melt all my ice. I cannot use the formula because delta T is 0. I have to use the heat of fusion that's expressed in kilojoule per mole. At C, all my ice is melted. Now I can increase from C to D my temperature of my water. I use the formula again, but now this is the C value for liquid H2O, so for water. At D, I am at 100 Celsius, the boiling point for water. From D to E, I'm going to evaporate all my water. Temperature is constant, so I cannot use the formula, but I use the information about the heat of vaporization, expressed in kilojoule per mole. At E, I can increase the temperature again to reach higher temperature of my steam. And I use the formula again, but now it's the C value for H2O in the gas phase. Let's practice with two steps of this curve. So let's assume we have ice. We have 9 grams of ice of -10. I want to increase it to a temperature of -5. And the heat capacity of ice is 2.08 joules per gram Celsius. Assess the energy or heat requirement. So we use the formula, Q is mc delta T, M is 9 grams, C is 2.08 joules per gram Celsius, and delta T from -10 to -5 is 5 Celsius. So when you calculate that correctly, it's about 93.6 joules. So increase the temperature of my ice. But now, let's see, I have ice, 9 gram ice at 0 Celsius, and I'm going to melt all these 9 grams. And I give you the information that the molar heat of fusion for ice is 6.02 kilojoule per mole. We cannot use the formula because delta T is 0, because it melts at 0 Celsius. The temperature is not going to increase during melting. But I know to melt 1 mole of ice, I need 6.02 kilojoules of energy. But do I have 1 mole? No, I don't, but I know I have 9 grams. So I have to calculate the number of moles again. Remember, mass divided by the molar mass gives me the number of moles. So what I do, 9 divided by 18 grams per mole for water gives me 0.5 or half a mole of H2O. So combine it with the information kilojoule per mole, 0.5 times 6.02 kilojoule per mole results in 3.01 kilojoule or 3010 joules. So now we calculated for 2 of the steps of my curve the energy use. Next, I'm going to do an experiment or assessment to assess the energy requirement to heat 180 grams of ice at a temperature of -10 to change to steam of 105 Celsius. And here's the information we need. Heat capacity of ice, of water vapor, the heat of fusion for ice to water, and the heat of vaporization for water to steam. How are we going to do that? Look for the other movie and I'll give an explanation or demonstration how we can apply all this information. So for next class, I want you to study 14.1b plus c And as a worksheet, I will upload a worksheet. It's about energy use, the heat for phase change. But next, look for the other movie with an explanation from the assessment I just talked about. Okay, that's it for today. Bye-bye. Good luck.